Now we can see Dijikra's algorithm, which is single source shortest path algorithm. It uses greedy technique from single source. So here this is a source node S. From this source node to all the remaining nodes, we have to find out the shortest distance. So how we can start the problem by assigning the weight values to each of the nodes. All the edge weights are given. So to the source, directly connected distance from the source we have to write. So directly connected nodes, with one edge connected nodes, we can write the distance. So source to itself, the distance is 0. To t, the distance we can write it as 10. The value is 10. To y, it's a direct connection, so we can write the value near to the node, we can write the value as 5. 5 is the distance. Then x is not, the node x is not directly connected to the source, so the value we can write it as, the distance value we can write it as infinity. Z also not directly connected to the source, so here we can write the value as infinity. The algorithm mainly does two steps: extract min and relax. These are the two steps. These two steps are repeatedly doing. So first it will do the extract min. That is, so now already we have taken the source vertex, and whatever the remaining vertices, these are the remaining vertices, from this we have to extract the minimum vertex, minimum weight vertex. That is the first one. So two procedures are there: extract min, after that relax. These are the two steps in this algorithm. So while doing extract min from the remaining vertices, the minimum vertex is, so here from the remaining vertices, the minimum vertex is now y, the 10, infinity, infinity, 5. So the minimum weight vertex is now y. So extract min, this vertex now we have added. This one we have added to our set minimum shortest path vertices. S is added, then y is added. Then next, after extract min, we have to do the relax. Relax means each of the vertices adjacent to y, we have to only check the vertices which are directly connected with y, and whether we have to check whether we can relax their weights through y. That means for y, these are the two directly connected, three directly connected vertices are there. One is t, and through this path x is also there, and also z. These are the three vertices which are directly connected adjacent to y, and we have to check whether their weights can be relaxed while considering y. So through y we have to calculate their weights. So taking the considering t currently now have weight 10. Through y, what is the weight to t? So the distance of y from source is 5, plus from y to t the distance is 3. So 5 plus 3 we will get 8. 8 is lesser than 10, so we can write the new value of the distance as 8. So the distance value we will write it as 8 because it is lesser, that is why we replace the value 10 by 8. Now we can see the other vertex x. X is currently having the value infinity. Through y, what is the value of x to from the source? So y distance from source is 5, and y to x the distance is 9. So 5 plus 9, it is 14. 14 which is lesser than infinity, so we can write the value 14. Replace the value 14. So the x is over. The next adjacent vertex to y is z. So z also we can consider its current value is infinity. Through y, what is the value what is the distance of z from source? That is 5 plus 2, which is 7, which is lesser than infinity, so we have replaced it with 7. So the relax procedure we have done. Then again extract min. These two procedures has to be repeatedly done. So now we have to, which is a minimum vertex we have to find out. T the value is 8, x the value is 14, Z the value is 7. So next minimum vertex is Z. So we had to extract Z. Z is taken. Then through Z we have to check whether we can relax the adjacent vertices of Z. So Z has only one adjacent vertex, X, which is unvisited. Unvisited also we have to see. So unvisited, so that is X. And check whether this weight of X, 14, whether it can be reduced if we take the distance from the source through Z. So Z the distance is 7 plus Z to X the distance is 6. So 7 plus 6 the value is 13, which is lesser than 14. So we can replace the value by 13. So that value we have replaced. So that relax procedure is over. Only one adjacent vertex for Z. So that is over. Then again extract min. So what are the remaining vertices? Only T and X. From that, which is the minimum vertex, minimum value we have to extract. So that is one is 8 and one is 13. So the minimum is 8. So we will be extracting the vertex T. Then the relax procedure. T is connected to the only adjacent vertex, unvisited vertex is now X. So we have to check through T we can reduce this 13, the value 13 of the distance X. So T, the distance from the source is 8, plus from T to X the distance is 1. So 8 plus 1 is 9, which is less than 13. So we can put the value 9. So that relax procedure is over. Then again extract min. Only one vertex is remaining. So that vertex we can extract. That is our X vertex. Then there is no vertex, adjacent vertex which is unvisited for relaxing. So this is finished. So after this problem is finished, so finally we will get the final values as the weights as a distance, shortest distance to each of the vertices. That is from S to T the shortest distance is 8. From the source S to X the shortest distance is 9. From the source S to Z the shortest distance is 7. And from S to Y the shortest distance is 5.